All right, 2.3, we're going to talk about polynomial and synthetic division. So we're going to be dividing polynomials using synthetic division and long division. So we can use division with polynomials. If it divides in evenly, it's going to be a factor of our polynomial. And factors, we know, are also x-intercepts. So here, we have an x-intercept at 2, 0. So that means 2 would be a 0 of our factor. So then if 2 is a 0 of our polynomial, then x minus 2 is a factor of our polynomial. Now, thinking about it mathematically, let's say I had 104, and 2 was a factor of 104. How would I find my remaining factors of 104? What would we do? We'd divide by 2. We'd divide 104 by 2 to see what else is a factor of it. So that's exactly what we're going to do with our polynomials. I see here that I have 2 other factors. Well, I knew that I had 2 factors because it's an x cubed polynomial. But in order to tell what those are, we're going to divide by the factor that we know and see what our remaining factors are. So we're going to do that in example 1. So here we're going to use long division. This one, when it's in x minus 2, you could definitely use synthetic division, but there's going to be cases where you have to use long division. So we're going to practice long division here. So x minus 2 is going to go on the outside, inside of our box. You always want to make sure when you put your polynomial inside the box that every term is represented. If you start with x to the 3rd power, you need x squared, x to the 1st power, and your constant. If you're missing one of your terms, you need to make sure you put a 0 in that spot. Here we've got all of our terms, so we're good to go. So 6x cubed minus 19x squared plus 16x minus 4. So the first step we do in long division is divide. We divide our first term by the first term, so it's 6x cubed divided by x. 6x squared. All right, so 6x cubed divided by x would be 6x squared. I'm going to write that on top of my x squared term. It's super helpful to keep your like terms in line. That way you know what's going to come next. Step 2 after we divide is we multiply. We're going to multiply everything up top, or what we just wrote up top, with everything out front. So 6x squared times x would be 6x cubed. And 6x squared times negative 2 would be negative 12x squared. Step 3 is we change the signs and combine. So change the sign, and combine. 6x cubes cancel. Negative 19x squared plus 12x squared would be negative 7x squared. So notice how still my like terms are in line. Now we go back from the top. We're going to divide again. What's negative 7x squared divided by x? Negative 7x. So I'm going to write that in line with my x terms. After we divide, we multiply. Negative 7x times both things out front. So negative 7x times x would be negative 7x squared. Negative 7x times negative 2 would be plus 14x. What's next? Change the signs and combine. So that becomes a plus and a minus. 7x squareds cancel. I'm going to drop down the 16x. 16x minus 14x would be 2x. Then we do it again. 2x divided by x would be 2. Then we multiply. We get 2x minus 4. Change the signs and combine. 2x cancels. Negative 4 plus 4 also cancels. So then we're left with 0. So here our remainder is 0. When your polynomial is a factor, here x minus 2 we knew was a factor, so it's going to divide in evenly. So that means our remainder is going to be 0. If you start off with a factor, it's going to divide in evenly. Your remainder is going to end up being 0. Now it asks us to factor the polynomial completely. So let's continue to factor it. We've got 6x squared minus 7x plus 2. You guys can factor this however you want. If you like to do grouping, that's fine. I'm going to multiply the first times the last. 6 times 2 is 12. What are two factors of 12 that add to negative 7? What? Negative 4, negative 3. So we have x minus 4 and x minus 3. If we start by multiplying, we have to remember to divide by that number. So I'm going to divide by 6. Simplify your fraction if you can. So I can simplify 4 over 6 to be 2 over 3. And then 3 goes in front of the x. So this would be 3x minus 2. 3 over 6 simplifies to 1/2. So 2 goes in front of the x. So this would be 2x minus 1. So 3x minus 2 and 2x minus 1 are also factors of it. I'm going to write my original factor, so that was x minus 2. If I FOILed these all out, I'd end up with my original polynomial, which was 6x cubed minus 19x squared, and so on. So these are my factors of my polynomial. If this question said to find the zeros or solve, we would just set each of our factors equal to 0. So our zeros would be 2 over 3, 1 over 2, and 2. So our x-intercepts are 2 over 3, 0, 1 over 2, 0, and 2, 0. Any questions here? We're going to do one more long division one. There's not another example in the notes, but the other class had a few questions from the homework. So I want to do one. There's one similar to this on the homework. Let's say we have x squared plus 1, and we're dividing that into x to the 5th power plus 9. When I write this in the box, I need to make sure every term is represented. So here, I need a 0 x to the 4th power, a 0 x to the 3rd power, a 0 x to the 2nd power, and a 0x. So these are just going to act as placeholders to keep my work consistent. So x to the 5th power plus 0 x to the 4th plus 0 x to the 3rd plus 0 x squared plus 0 x plus 9. I think that this is one similar to the homework. It might not have as many zeros, but something like this. Outside, you don't need a 0 as a placeholder. Inside, you do. So first step is we're going to divide. What's x to the 5th power divided by x squared? If I have 5 x's and I take 2 away, how many am I left with? 3. So x to the 3rd power. I'm going to write that right on top of my x cubed term. Now I'm going to multiply. So we multiply x cubed with everything out front. So this would be x to the 5th power. X cubed times 1 would be 1x cubed. So I'm going to write that on top of my, or right below my x cubed term. You want to keep your like terms in line. Next step, we change the signs and combine. X to the 5th powers cancel, and we're left with negative 1x cubed. I don't need to drop down the 0 to the 4th power because I don't have anything to combine it with, so we can just move on. Now we're going to divide again. What's negative 1x to the 3rd power divided by x squared? Negative x. So I'm going to write that on top of my x term. Just keep everything in line. Negative x times x squared would be negative x cubed. Negative x times 1 would be negative x. Change the signs and combine. X cubes cancel. I don't have anything to combine with the 0x squared, so I can ignore that. 0x plus x would just be x plus 9. Now, can I divide x by x squared? No, I can't take 2 x's away from x. So what do you think happens next? Awesome. X plus 9 is our remainder. So we write our remainder as a fraction. So I have x cubed minus x, and then plus x plus 9 over what I divided into it, so my divisor, x squared plus 1. So that would be our answer. Next, we're going to do synthetic division. So synthetic division is like the shortcut for long division. It only works when you have a binomial, so something in the term of x plus a number, x minus a number. If you had x squared, synthetic division is not going to work. So if we had x minus k, what would x equal here? For x minus k, what would x equal? K. If I set it equal to 0, x would equal k. So k is going to go outside. If I had something like x minus 2, and I was doing synthetic division, 2 would go outside, whatever x is equal to. So you would always want to change the sign when it's written as a binomial as x plus or x minus. And then the steps that we're going to follow for synthetic division, outside of the box, we multiply. So when you write a number outside, the next step is to multiply it by that number up top. Inside the box, you're going to add the terms. So if something's written on top, you add them together. So example 2, it gives us the box, kind of help us to start off with. But inside of our box, we put our coefficients. Just like with long division, you need to make sure all of your terms are represented. So if I start with x to the 4th power, I need x to the 3rd power, x to the 2nd power, x to the 1st power, and our constant. So here, I'm missing x to the 3rd power. So I need to put a 0 in that spot. So that's why inside the box we have 1, 0, negative 10, negative 2, and 4. All of our coefficients go inside the box, but you need to make sure you include any terms that you're missing. And then here we have x plus 3, so x would equal negative 3. Negative 3 goes outside the box. First step, once we're set up, we drop down the first number, multiply on the outside, so we get negative 3. Add on the inside. 0 plus negative 3 would be negative 3. Multiply on the outside. Negative 3 times negative 3 is 9. 9 minus 10 would be negative 1. Multiply on the outside. Negative 3 times negative 1 is positive 3. Add on the inside. Negative 2 plus 3 is 1. Multiply on the outside. Negative 3 times 1 is negative 3. Add on the inside. We get 1. So now when we write our answer, we started with x to the 4th power, and we took away an x plus 3. We divided that. So we're going to be one variable less. So if I start with x to the 4th power, my answer is going to start with x to the 3rd power. And then we just decrease from there. X to the 3rd power minus 3x squared minus 1x plus 1 is our constant. The very last number is going to be our remainder. So this would be x cubed minus 3x squared minus x plus 1. Our remainder, we want to write it as a fraction, so it'd be plus 1 over our divisor, which was x plus 3. So this would be our answer. We can use synthetic division along with the remainder theorem to evaluate a number in that polynomial. So it could say evaluate f of 10. We'd put 10 on the outside of our synthetic division. Use synthetic division to divide your polynomial. That's what you get. Your remainder is what you'd get if you evaluate. Let me write that down in better words. So if I had something like f of 5, if it asked me to find f of 5 in my polynomial, I would use synthetic division. 5 would go on the outside. Whatever my remainder is, so that last number, my remainder would be my answer. So f of 5, if I were to evaluate f of 5, it would be what we get as a remainder. So if it says use the remainder theorem to evaluate, just the remainder is your answer. Let's practice. So in example 3, it says use the remainder theorem to evaluate the following function at x equals -2. Well, I can plug -2 into all my x's and work it out, but that's going to be a lot more work than what we need to do. So to evaluate x at -2, I'm going to do synthetic division. So -2 goes on the outside. Hola. Inside the box, we put our coefficients. Make sure no terms are missing. So we've got x to the third power, x to the second power, x to the first power, and our constant. So we can go ahead, put all of our coefficients in the box, 3, 8, 5, -7. First step is we drop down the 3, multiply on the outside, we get -6, add on the inside, 2. 2 times -2 would be -4, plus 5 is 1, times -2 is -2, plus -7 would be -9. So what is f of -2? -9, just the remainder. If it says evaluate, it's just looking for the remainder. We also have a factor theorem, so kind of like back to that first example we did. If we use synthetic division and get the remainder of 0, then our polynomial is a factor, or binomial is a factor of the polynomial. So it says the polynomial f of x has a factor x minus k if and only if f of k is equal to 0. So if we do synthetic division and we get a remainder of 0, then it's a factor. In example 4, it says show that x minus 2 and x plus 3 are factors, then find the remaining factors. So we're going to use synthetic division, and if we get 0 as our remainder, then we know that it's a factor. So I'm going to start by dividing x minus 2. What's going to go on the outside? 2. On the inside, we put our coefficients. We've got x to the fourth power, third power, second power, first power, constant. So we're not missing anything, so we're good. So 2, 7, -4, -27, and -18. We always start by dropping down the first number, multiply on the outside. 2 times 2 would be 4. 4 plus 7 is 11. 11 times 2 is 22. 22 minus 4 is 18. 2 times 18 is 36. Minus 27 would be 9. 9 times 2 is 18. 18 minus 18, 0. Is x plus 2 a factor? Yes. We just showed that x minus 2 is a factor because we got 0 as the remainder. Next, let's show that x plus 3 is a factor. So instead of doing synthetic division again and putting my original polynomial, I'm going to work with what I just divided, because if it was a factor of my answer now that I have, it would have been a factor of my original too. So we're going to divide x plus 3 into my coefficients that I have here. What's going to go outside the box? -3. So I drop down the 2, multiply, we get -6, add 5, multiply, -15, add 3, multiply, -9, add 0. Does it work? Yep, so x plus 3 is a factor also. Now it asks to find the remaining factors. So I'm going to use my answer to find the remaining factors. If I started with x to the fourth power, when I divided the first time, this would be x to the third power. When I divide it again, now this would be x squared. We have 2x squared plus 5x plus 3. So let's factor 2x squared plus 5x plus 3. So I'm going to multiply the first times the last. We get 6. What are two factors of 6 that add to 5? 2 and 3. Perfect. So we have x plus 2 and x plus 3. What do we do next? Do what? Divide by 2. So I'm going to divide both of these by 2. Simplify where we can. So we have x plus 1 and 2x plus 3. So these are my remaining factors. If it asks for all of my factors, I'd also have to include x plus 3 and x minus 2. These would be all of my factors of my polynomial. And then if it asks for the zeros, just for extra practice, let's find our zeros. What would x equal? Perfect. It's 2, -3, -1, and -3 over 2. And then we kind of talked about it in 2.1 and 2.2 a little bit. If we have x to the 4th power, we're going to end up with 4 zeros. We'll have 4 factors and 4 zeros. If you have x to the 3rd power, you'll end up with 3 factors and 3 zeros. So whatever your highest degree term is, that tells you how many factors you'll end up with.